Hello friends, welcome to my YouTube channel Engineering Modules. So friends, today I am going to discuss about numericals on nodal analysis or application of KCL. So I taught in my previous video about nodal analysis. So friends, today I go through this teaching with numerical problems. So let's start with a circuit diagram. So friends, this is the circuit diagram and the question is calculate current and voltage drop through 5 ohm resistor. So with the application of nodal analysis, we need to calculate the voltage drops between 5 ohm resistor and the current through 5 ohm resistor. So let's start the problem. So friends, in my previous video I say that in nodal analysis we need to find in the circuit diagram that which points are creating a node. So in this circuit diagram we see that this is one node, this is second node and this is third node, and we also assume that the voltage in first node is V1, second node in V2 and third node is V3. So we need to equate some equations with respect to node 1, node 2 and node 3. So with respect to node 1, the equation is, so for node 1 the equation is V1 minus V2 divided by 5 plus V1 minus V3 divided by 4 plus 1 equal to 0. As we assume this V1 as the highest potential, so we need to flow this current from V1 to V3, V1 to V2 and V1 to this ground voltage. So this is plus 1, this is V1 minus V2 by 5, this is V1 minus V3 by 4. So this is the equation for node 1. As we see that in KCL the sigma IR equal to 0. So with this apply in this equation. In this way we calculate the equations for node 2 and node 3. So let's proceed. So for node 2 the equation is V2 minus V1 by 5 plus V2 by 1 minus 2 equal to 0, and node 3 V3 minus V1 by 4 plus V3 by 2 plus 2 equal to 0. In node 3 V3 is the highest positive terminal and in node 2 V2 is the highest positive potential. So we get 3 equations from the 3 node analysis. Then we solve this equation and we need to find V1 and V2 for calculate current and voltage drop through 5 ohm resistor. So we use comparison method or exchanging method for this solving, but I suggest that use the matrix method to solve this equation. So the matrix form of these 3 equations are, so the matrix equation is like this, and this is the form of Ax equal to B. So we find V1, V2 and V3. But for our calculation of current and voltage drop through 5 ohm resistor, we need to calculate V1 and V2 only. So by Kramers rule, solving the equation, we need to calculate del 1 and del 2. So del 1 and del 2 is, so the value of del equals to 0.3 and del 1 equals to minus 1.2 and del 2 equals to minus 0.3. So the value of V1 and V2 equals to, so the value of V1 is minus 4 volt and V2 is 1 volt. So now we easily calculate the current and voltage drop through 5 ohm resistor. So the current and voltage drop through 5 ohm resistor is, so current through the 5 ohm resistor is minus 1 ampere and voltage drop is minus 5 volt. So this is the process to solve a circuit with nodal analysis. So this is all about the circuit solve with respect to nodal analysis. So this is for today, friends, and in my next videos I will also describe about circuit solving using mesh analysis and also the other things on circuit theory. So this is for today. Please like, share and subscribe my channel and keep watching for either updates. So this is for today and thank you.